Hi there, I'm Matt Adams with Loop. One of the fun parts about having worked with so many different machine builders is that you get to see the same patterns show up in completely different industries. For example, there's a ton of machines that need to have I/O signal handling with microsecond level precision. And because of this, a lot of machine builders have built their own custom boards because you won't be able to get that kind of speed with an off-the-shelf PLC. If you look at the typical architecture patterns of these types of machines, it's usually an in-house built PC running a general purpose operating system like Windows or Linux. And that's connected to a front-end display for an operator to interface with. The PC is also communicating to a dedicated board that does high-speed I/O. Now, going into these I/O boards are a mixture of input signals, and often there's a line encoder from a conveyor and a high-speed product detecting sensor. Sometimes you'll also see an additional sensor to do some precision measurement or maybe some inspection along the way. And then based on a combination of time, travel distance, and some of those sensor measurements, outputs are triggered, and that's where the magic happens. The glue pattern, laser firing, or that physical rejecting of a product while it's in motion. Now these processes are so performance intensive that there was never really a make versus buy decision to be had. The only option was to make it yourself. Now, fortunately, a lot has changed over the past few years, so if you're working in the world of custom embedded controls, I want to review some of the advancements from the industrial controls ecosystem with you. Now, combining industrial PCs and industrial panels has been common for the last 10 years or so, but something more recent is the idea of combining a general purpose operating system like Windows or Linux with a real-time operating system. We do this by having them run on different cores on the same PC. The underpinning technology of this is called Hypervisor, and we have a really nice video of this on our YouTube channel you can look at. Something that's new to this technology is the idea of sharing memory at the hardware layer, which eliminates all the communication delays between them. Consolidated hardware doesn't solve the I/O speed problem though, because in the traditional controls world, a centrally managed CPU is running logic and reading and writing I/O along a field bus or backplane, which are milliseconds fast at best. Now today, B&R addresses these with two I/O families that are using the same technologies as in embedded controls: digital signal processors, DSPs, and field programmable gate arrays, FPGAs. So instead of controlling I/O at the CPU level, you're configuring and programming slices directly at the signal edge. Now, specifically, the DSP family consists of three products that are suitable for edge generating, encoder capturing, high-speed outputs, or encoder emulation, and they operate at a couple of voltages which are common. And the FPGA family goes under the Reaction brand name, and this consists of six products with both a mix of digital and analog I/O. Now, what's so revolutionary about both of these products, though, is they improve the output resolution speeds by at least 1,000. So we're moving here from the millisecond range to the microsecond range, and that's what brings embedded performance to off-the-shelf products. So if you're currently a machine or equipment builder with embedded controls, or maybe you're using an off-the-shelf PLC that could really benefit from this kind of performance improvement, reach out to me or anyone here at Loop. We'll collaborate and see if we can bring some revolutionary improvement to your machine.